Next slide.
Is that better?
Yep, that looks great.
Okay.
Cool. Okay, let me. Great. Hi, everyone. Thank you for joining us. Thank you for joining the DataCon LA 2020. Welcome to the data infrastructure and security track. And soon we'll be listening to the Becoming a Data-Driven Organization Through Unified Metadata using ODPi Egeria session with Mandy Chessell. I'm Annie Flippo, your host, and our co-host today is Sachin Nahar, and we'll be monitoring the chat and Q&A for the duration of this session. Mandy is an IBM Distinguished Engineer, Master Inventor, and the Fellow of the Royal Academy of Engineering. Mandy is a trusted advisor to executives from large organizations, working with them to develop their strategy and architecture relating to governance, integration, and management of information. She's also driving the IBM strategic move to open metadata and governance through participation in the Egeria open source project. So without further ado, I'll hand over to the speaker. Thanks for being here, Mandy.
Thank you, and thanks for a lovely introduction. So what's this talk about? So as Annie's already said, I work for IBM, but actually I spend all my time working on an open source project. And the reason is that we're trying to change the industry. We're trying to change the way that IT systems work and the way that they handle data and their knowledge of data and digital systems. And the aim is to get to a point where there's good transparency on the types of digital resources that an organization has. So I'm going to take you through the journey and the questions and the sort of the types of issues that we're trying to address to give you a bit of a feel for the impact that we're trying to have with this extremely exciting initiative. So let's talk about what we've been through in the last 6 months. As we know, almost every organization, I mean, all of us have been through a huge amount of turmoil. And the result is, I mean, from an organizational point of view, everything has changed, and the way people are working, the way their resources are put together and are deployed and being used, and the priorities have changed. And for an organization to do that, they really need to be able to understand the resources they have, how healthy they are, where they are located, and how much flexibility they have for change so that they can reconfigure. Because generally most organizations are fairly rigidly structured for today's business, and when today's business sort of changes dramatically, then any over rigidity and silos start to create problems. And the reason that we have silos is actually the way our tools work. We have lots of different professionals in the organization, all using digital tools. And but these digital tools are sort of, they're in their own little world, and they gather knowledge. Even a sort of simple editing tool will remember the last set of files that you've worked with. But there are more sophisticated tools that are really gathering information about the sort of the knowledge that you and your team who are using the tools are gathering. But as I say, that it's all fragmented. So that means that it's fine when the organization is stable, everybody knows the right people, and people fill in the gaps that the tools leave. But when things change, suddenly these silos create problems. So I'm going to talk through an example of what it could be like if the tools could share metadata or this knowledge that I'm talking about more easily. And you're probably thinking, well, surely there are lots of standards in this space. And actually there are. There are hundreds, maybe thousands of standards, and they all focus on something very, very specific. And what we're looking at is saying, well, actually we need more. We need to think about the whole ecosystem and link things together in a much more holistic way. I mean, effectively our entire lives are now digitized. And so the tools and that sort of background knowledge exchange needs to cover that breadth. So as I say, let's look at what it could be like. Now, for a lot of industries, particularly regulated industries, it's useful to have a definition of all the terms that people use and what they mean and the data associated with it. And we call this a glossary or a vocabulary. And you know, because lots of jargon basically in most businesses, and this helps clarify it. And different parts of the same business actually might use language quite differently. And so when we're trying to get control of data and allow it to be much more understandable and shareable, one of the things we do is we build these glossaries. And because they're written in natural language, the business experts can actually read it, work with it. They probably created a lot of the definitions, but they also know what the implications around the regulations and the use of any data that covers these terms. So for example, if you have something like credit card and credit card number, these are terms that would be in the vocabulary, and the business would know, well, actually, this is financial information. It's actually sensitive because if the organization loses a person's credit card number, then that person is open to fraud. So it needs special treatment. And we can do this with all the terms. So there'll be most of them will be sort of like not actually specifically sensitive, but there'll be certain things, particularly around people, finance, results of the organization that are sensitive, and they need a special treatment. And that can be reflected in the tagging in the vocabulary. Now, most of these vocabularies are digitized, so they can be shared, but they're generally in a private format. But if we could share it, imagine a team of software developers building APIs, databases, and things. If their tools could embrace that knowledge that's described in the vocabulary, then the developers would be much faster. So one of the examples that we've worked with in a particular company is that they took the Swagger tooling. That's this tooling that helps developers build APIs. And they basically created a search box, and the developer can say, I want to build an API about customer data. And what would happen is that the payload, all of the sort of fields that would be sent over that API, are then sort of automatically pasted into the API. And this could be, 20 to 30 fields that the developer now doesn't have to type in. And so they're happy because there's a lot less typing, and they've got less rework because they're less likely to miss something out because it's being handled for them. So they actually get their code into production, into the DevOps pipeline, which is the sort of pipeline that takes it through to production use much faster. The other thing is that because it's come from that vocabulary, all those little tags that said where the sensitive data is located, for example, came with it and actually were attached to the API automatically. And so when the DevOps pipeline picks up that code, it can say, oh, wait a minute, this has got sensitive data in it. It needs special testing. It needs to be deployed into a secure environment. So the DevOps pipeline is now operating on the understanding of the data and the requirements for that data that is inherent in the function that the developer built. So here we have a situation where at least two groups are now far more productive because we've managed to move metadata between a set of very different tools. So time passes, and the application that the developer built is running, gathering data. And so it's gathering data about customers. And someone says, well, we can do more for our customers if we understand them a bit better. And so a data scientist is commissioned to do some analysis to see if they can understand the customer data much more effectively. Now, to do this, they can't just attach to the runtime, to the operational system. They need to take a copy. And there's two reasons for taking a copy. What they're going to do is very disruptive. They're going to manipulate the data and do lots of experiments with it. But the other thing is there's certain data in there that the data scientist doesn't need in order to do their job. And so often we pull data out into the tools that the data scientist is using. and allowing them to work freely and disconnected from the actual live system. But because, again, this system was built and tagged through that process that we talked about, the process that populates the data science tool actually can take note of where the sensitive data is, maybe filter it out, do certain types of obfuscation of that data, so that the data scientists can work knowing that they are operating legally and with proper respect for the data. So I hope you can see that by linking these tools together and allowing that flow through, the business is behaving much more consistently, and individuals are able to work much more effectively than they could before. And that's really what we're trying to achieve, which is basically saying we need to get to a place where tools can share metadata. And it's a sharing process. It's not, let's have a centralized metadata that everything has to connect to, because that's really never going to work. We have to make this a flow of metadata that maintains the integrity of that metadata as it moves through the process. Now, if you've been in the industry a long time, as like myself, you will know that this has been a dream for a very long time. And we've had lots and lots of attempts across the industry to try and share metadata. And there are many scars from that attempt. And basically, the problem is that most tools have their own database, and they need that database locally, and it's optimized format for them to operate properly. So we have to preserve that while still allowing the sharing. And so Egeria's role is, well, first of all, we have to build trust in the people that are involved. So making it open source means that it can be a sort of open discussion about what the standards are, how it works. People can look at the code, they can say, well, wait a minute, yes, this is fair, this is actually correct as well. It's not going to corrupt the metadata as it flows through. And so we get a strong collaboration and expertise coming together to solve this problem. So the open source aspect is very important. But we also build the actual technology itself to operate in a peer-to-peer way. So there's no tool that's in charge. It's all about tools sharing what they can, consuming what they can through a standard set of types. You can think of that as a language. So that each tool can operate at its best, sharing as much as it knows, but not requiring other tools to be dumbed down to meet the lowest common denominator. That's the goal. It also has to scale. It has to run on the smallest devices like Raspberry Pis, right up to very large multi-tenant, highly available global cloud services as well. So that's another challenge we have. And the security has to go very fine-grained, because some metadata can be extremely sensitive, and in fact more sensitive than the data it describes, because it's aggregated knowledge. So we need to be able to share, but also to be able to restrict visibility for different reasons. The other thing is that because we're connecting things that have never been connected together, the opportunity for innovation is incredible. And so we operate in a very iterative process, again, very collaborative, open about what we're doing, because it's actually an amazing environment to work in when you've got people from different backgrounds trying to solve the same problem, and the perspectives that come up really create an amazing solution. And I don't think this project could have got anywhere near as fast if if a single company had tried to do this. So certainly the open collaborative aspect of this project has been incredibly valuable. And the result is that we've been going just over 2 years, and we have a huge number of achievements in terms of building this open integration peer-to-peer ecosystem. So I'm going to spend a little bit of time talking about how it works, and then then more about the actual project itself, and give you an opportunity to connect with us and maybe become part of the team. So I talked about peer-to-peer, and of course that's extremely important. So here we've got a series of tools doing different things: development, DevOps, data science, as in the early example. And each of these tools have their metadata repository. So this is where their configuration and knowledge about the things that the users of the tools are working on is kept. And because each group is doing slightly different work, each repository will have a slightly different view of the data and the sort of services and APIs and systems that those tools are working with. So there's a slightly myopic view with them. And so Egeria is a set of libraries. It can sit actually embedded in the tool. So if the tool has natively embedded Egeria in its support, the Egeria library sit in it, or we can create adapters that sit between pushing and pulling metadata in and out of the different repositories. Now this sounds, people might say, well, that's just a question of sending data. But actually, it requires an awful lot of careful code to make this work, because effectively you are exchanging metadata between two different applications that use different structures for that data, and maybe different granularity in terms of the way it operates. All the tools are updating the data at the same time, and we need to exchange it while maintaining complete integrity in that data. So there are many impedance mismatches between the different tools, and that's Egeria's job to, as I say, to make each tool operate at its maximum, at its best, but still enable the exchange. So when we're working well, you can't see it, and that's the aim, is that actually over time Egeria will disappear. It will be something that's embedded by default in tools. You just expect it in the way that you expect security on your laptop today. That's our goal. At the moment, as I say, we have to have these adapters with our own platform that is pushing and pulling metadata to enable things that were built without knowledge of Egeria at the time that they were released. Right. So what have we done? We've built a common language, and this actually, so this language is about, it's a sort of logical graph of objects, relationships, and additional things called classifications that can be attached to the objects. There are about 500 different concepts, different types within this common language. And then, of course, there are the data structures to flow across the network. And we combine replication of metadata with the ability to do a federated query. So once the tools are connected, any tool can query and retrieve metadata from any of the other connected tools. Back to this peer-to-peer notion. So that's a key part of the protocol that we have. The other thing is we try to minimize the cost of bringing in a new technology. So we try to do as much of the work. And so the connectors that actually connect to a particular technology are really just doing translation between the Egeria API and the tool API. And so we try to get that to, because we really want it to be, not a major effort for a particular vendor or open source project to actually become part of the ecosystem. So if we looked at Egeria sort of at a sort of very simplistic way, you would see lots of different types of tools with a connector that's pushing and pulling metadata, so sending and receiving that metadata. But of course, when you look at technology today, it's very diverse, it's very distributed, it's on different cloud platforms, it's in different data centers, it's big, it's small, very distributed. Now, if we thought of Egeria as a centralized thing, of course, that would just really not work from a availability network point of view. So Egeria is located where the tools are, and it then communicates with the different parts of itself that are distributed. We also support formats for when data is exchanged between different organizations that don't want to connect their repositories together. There's actually an export and import format that allows metadata to flow with data. So it could have, you know, sort of classifications, the meaning, the terms and conditions, or the, you know, sort of any special considerations that need to come, that need to be taken into account by the receiving party. And then, of course, because it's in open metadata format, it can be loaded into the specific types of tools that the receiving organization is using, and then, you know, sort of be part of the ecosystem in that organization. So here's another picture of it. And this is the picture you'd see if you went to our website. Again, showing the fact that Egeria is located with the tools. So it's co-located, and the blue square is like a platform, and that can start and stop and be managed with the collection of tools that it's supporting. And then in the platform, we put a set of servers, and these are sort of logical servers. They are configured to host a particular type of connector, and that connector connects to a particular type of tool. And I use the word particular type because depending on the type of tool, will depend on the type of metadata it needs, and also its sophistication in terms of working with metadata. So we have different integration points that suit specific types of technologies. Again, all back to making it as easy as possible for technologies to become part of the ecosystem. And the connectors, all of the connectors follow the same framework. So once you get used to the connectors, you once you've written one, you can write another, and it's they're managed the way that the code is loaded and configured is all consistent. And so that applies to the connectors that we plug into Egeria to allow to make to provide it with resources so that it's a very portable technology, but also we use connectors to connect into external applications and into our runtime to allow third-party technologies to connect in. So connections, there are lots of connections, and as I said, there were different ways that different types of connection points, and that's the where technology connects in depends on its sophistication. So in the center are metadata repositories. These are technologies that their sole purpose is to be metadata repositories. They're good at it, right? They support a very wide range of metadata, and so they join what's called a cohort, and that's that central peer-to-peer sharing of metadata and the federated queries. So the technologies that sit in this center have to be quite good because they have to field queries from other servers as well as work with the replication exchange. And so technology can embed Egeria and join the cohort. It can also sort of have what we call a repository proxy. This is an adapter that sits on the outside, talking to the third party technology in its language and translating that and talking to the cohort in the open technology language, open metadata language. So that's the core, and that gives us that integrated metadata story. But gathering metadata is not so useful. We want to use it. And so we have governance servers, and their job is to push and pull metadata from different types of technology. So the technology doesn't need to be aware of Egeria, of the rest of the ecosystem. They just see a process using its APIs and events to push and pull metadata to and from it. So that's the technology. And then, of course, people have to be a part of this. They need to see the metadata. They need to be able to use it. There need to be sort of administrators and governance people looking at it. And so we have a view server that is providing REST APIs to user interface type technology, and Egeria has its own user interfaces, but also the expectation is that third-party tools will also connect into the view server and the other servers in the ecosystem. And the way that the servers are written is that the platform, the blue square, doesn't know what type of server it's running. It just runs multi-tenant, lots of different servers, whether they're all the same type or each different type. It doesn't care. And then based on the configuration that's passed to it, the personality effectively of the server is defined, and it will start up different resources, connect in, and perform different behaviors depending on that configuration, which defines what type of server it is. So I'm going to dig a little bit deeper. So that blue platform is the OMAG server platform on this picture, and here we can see it operating in a sort of, so imagine a small business with a variety of tools, single platform, all of the servers connecting, all of the tools in a single stack. Right out on the edge, you might have a set of sensors that are gathering data or making decisions. So you'd have a platform with maybe only one server on it. Or you might be in a very large, horizontally scaled, highly available system where the servers actually are run on multiple platforms, but they operate as a single service. And so the platforms can be started and stopped and upgraded. You can do a rolling upgrade across the cluster of platforms, but the server still provides the external service in a seamless way. A few more pictures, very different ways of that Egeria works. So we talked about that central core, the cohort group. And here we have an example of 3 different tools connecting through a cohort called cohort A. And they're connecting, depending on their capability in different ways. But once they're connected, the others are completely unaware of how a particular server connects. Once they're part of this, they can each see each other's metadata, assuming the security is set to allow that, but technically they can. It's also possible for a server to connect to, or tool to connect to, multiple cohorts, and then they will see the superset of everything. So in this example, the ones that are only connected to cohort A will only see the metadata from the members of cohort A. But the Chief Data Office and Centre will see the combined metadata from both cohort A and cohort B. So you can have sort of cohorts covering divisions of an organization. Then when you have the more enterprise type teams, then they would want to connect to multiple cohorts. And it has to be self-configuring because not everybody has very large IT teams that can run this. So we've tried to make Egeria as self-managing and self-configuring as possible. So the way the cohort forms, there isn't a central configuration that describes the cohort. Basically, the servers or the tools register with a Kafka topic, and it's called the OMASS topic. And so here we've got server 1, and they put their registration information into the topic. And they wait until another server comes along, puts their registration in, and then they have an exchange. And what they're exchanging is their configuration and their capabilities. You can see I'm getting a green, which means we need to start to think about finishing. So once that configuration has happened, then they can start to share they can share each other's metadata. So you can see that blue metadata is appearing on the pink screens and pink metadata is appearing on the blue. And of course we can, behind the scenes, we can also replicate metadata to increase its availability, particularly where you've got stuff that everybody's using and changes very, very infrequently. So this is really just an optimization through this federation. And I talked to Ben about, this is a large virtual graph, entities, relationships, and classifications. And what we're doing behind the scenes is we're shuffling stuff around to connect it together, because each has a subset view of the content. So we can shuffle. So here we've got a glossary term shuffling into another server, and it's shown dotted line because it's read only. When it's copied, it becomes read only. And here we can create a relationship, or we can shuffle it into a third server if, for example, the others didn't support both types of metadata on the relationship, and we can store it somewhere else. It doesn't actually matter where we store it, because when you query it, you will see the 3 connected elements. And it means that we can augment when we add governance on top, even though the base tools don't support that capability. So here we put a confidential label on the glossary term, which is saying that this database column is confidential. And the breadth of what we've had to cover is pretty broad. It's covering almost all parts of the digital operation, and has involved piecing together standards, many different types of standards, because the standards are very important, because some tools actually work with the standards, and if we can have a close sort of affiliation with the standards, then it's a lot easier for us to exchange. Plus, we benefit from all the effort that went into building the standards. So there were no standards that actually covered everything we needed. So it is a gluing together of, or a patchwork quilt, as I say, of the different standards. And here you can see the how they link together and build up all the relationships that we need in the business. And there are sort of 2 layers in the technology. There's the sort of fine-grained, deep integration, which is that core cohort repository services we talk about, and then simplified interfaces designed for particular types of tools that are what we call the access services. And they sort of focus on a particular part of the model to provide support for specific tools that are largely focused on a particular type of content. And then the governance servers, I talked about those, support different integration patterns so that they can be matched with the actual capability of the particular technology. Again, this is all about reducing the implementation that's specific to a particular technology as far as possible. So we can do things by having different platforms in different places connecting to different servers. We can react to when things change, gather metadata, distribute it, allow other tools to build on that, and create a very dynamic sharing of knowledge that is not only bringing knowledge to people, but is also pushing and configuring other technologies based on what's happening elsewhere. There's a lot of work that's had to be done around visibility, grouping, creating the sort of the visibility that was there through the silos of the tools, but making it more of a virtual dynamic thing that can be very easily changed and reconfigured, rather than being hardened in the tool boundaries that we had before. So we have these zones that can allow assets that we're gathering to be grouped in lots of different ways, and an asset can be grouped in many different in multiple ways, and it's actually just a tag inside the asset, so you don't have to physically move or copy stuff around. You just update the tags to change its membership, and through this we can do a huge number of governance governance type use cases, because we are able to sort of act on a group of so another warning, the group of assets that are within a particular zone. For example, use the zone settings to define what is retrievable through a particular API that the tools can be using. And then this metadata security goes right down into the repository. It does both sort of service type security, but also data-oriented security as well. And we need to make very sure that we know where everything came from, so that if anything's wrong, we can trace it and fix it. So provenance of metadata is deeply embedded into all of the protocols. And automation, actually our runtime has to behave itself so that it can be properly managed. So we have the Audit Log Framework that provides externalized translatable diagnostics for everything that we're doing. Nearly there. So user interfaces, this wasn't something that we were going to build, but it's proved a very popular request. So we have a lot of graph-based user interfaces that allow you to look at different aspects of the ecosystem that's working. So this is the repository explorer that allows you to connect into a tool, but actually see the metadata, all of the metadata from across the tools connected together through a single user experience. And we're getting an increasing number of vendors wanting to work with us to embed Egeria into their products, not just to be part of the big thing, but even just to support their own portfolio and how they connect across their customers' ecosystems and connect to other tools, keeping their costs down in terms of maintaining this integration technology. So Egeria is helping them both build their function, but also reduce their costs. And it's a big project. You can probably guess from all the different things that we're doing. We do have a very iterative open process. That means that we are pushing out new releases every month. So this module picture, and if I show you, I should use Death Star because it's a nice picture of sort of something that's working, but also the fact that there's building going on all the time. And that's really what it's like in Egeria. So here you can see there are a lot of green areas. This is stuff that's production ready, but there's other things that are sort of bubbling up, and you can see we start at the bottom and we're working up to higher and higher levels of function. Oh yes, this is the areas we're working on. So a lot on lineage, a lot on integration, additional implementations of connectors, more user interfaces, and just basically increasing the ability, the ease with which you can deploy and manage the system. So we're nearly finished. So I hope you've enjoyed this. I mean, this project has been a dream to work on. I've been involved in the planning of it and in the implementation for about 4 years. And it really is beginning to come together. So I hope you enjoyed the talk and are interested to click on to our site, and hopefully I'll talk to you soon. Thank you very much. There's a few links at the back of the presentation if you're interested.
Thank you, Mandy. Let's check our Q&A or chat if there's any questions. I don't see any right now.
Okay.
Well, thank you, Mandy, for your presentation. That was very enlightening. I have a quick question. So this sounds like a very new project. It's been only around a couple of years, right?
Yeah.
Has any organization successfully deployed this, and how have that helped them?
Yeah, so we have well, IBM itself has been using Egeria for over a year now, actually within one of its products, and it uses to synchronize 2 repositories, and no one knows it's there because it's just it's officially exchanging, and it looks like there's only 1 repository in the product. So we have had it has had a lot of exercising through that process. We have another company that is about to go into production through it, and then we have multiple vendors who are currently embedding it in their products, and you will hear from them during their announcements. In the next few months to year, you'll start to hear some very large household names talking about Egeria.
Oh, that's wonderful. It seems like a superpower product, but it's not like, client facing. It does the heavy lifting behind the scenes.
Yes, that's the idea. Yeah, you should. If it's working well, you shouldn't see it.
Well, thank you, Mandy, for your presentation. It was wonderful. If there was any questions people can think of, feel free to connect up with Mandy.
Yeah,
we have Q&A.
Yeah, back in the email, and I will look for the Q&A as well.
Yep. Yeah. And they'll, if you're okay, people can connect with you through LinkedIn as well.
Yes, please.
Okay.
All
Thank
right.
you.
Bye, everybody.
Bye-bye.